Welcome back to another CCIE Security Labs with myself, Kelvin. In this particular video today, we're going to take a look at how to configure DMVPN on Cisco iOS devices. Now, just before getting into the slides that I've got today and then on to the lab, I just want to point out for those that are used to viewing my content, maybe have realized that I've changed the slide from covering main points to summary. And that's the way I'm going to sort of deliver these sort of moving forward. And the reason being is because I really wanted to get across the point that these particular demonstrations are aimed more towards the lab environment. So it's to show you how to configure the different blueprint topics that are covered in the CCIE security and show you how you can work with certain features and technologies that may also be covered within the exam as well. And it's because I know that everybody doesn't really have the resources available to be able to actually configure a lot of the things that are on the blueprint today. So these sessions really focus on the technical side of things more than the theory. So it is expected that when you are viewing these demonstrations that you at least come into each session with some foundational knowledge of what it is that we're going to be covering, and that'll just help you follow along a lot better with the demonstrations that we run through for each of these topics that we cover. So moving forward, I will still cover the only real difference is changing from main points to summary, because I just want to sort of give you some main points or some summary points for each of the blueprint topics that we cover, with the intention of going more in depth in the lab. And if you do need to sort of read up further on any of the topics that we're covering, then you go and seek that information in the books or online, whatever it may be. So without further ado, let's get into the summary points here that I have with DMVPN. So for those that have followed my previous CCIE security focus labs, you will know that we've covered quite a few different VPN solutions and how we can configure VPNs in different ways. Now with DMVPN, when it comes to sort of large scale networks or multiple sites, we tend to look to DMVPN for VPN deployments. And the reason being is because it is a scalable solution. It only really requires minimal configuration in order to sort of connect all the sites together. And we can either choose to configure DMVPN as a partial mesh, so hub and spoke deployment. So that's where, let's say, your branch sites connect back to maybe a central location, maybe the headquarters. Or we can actually configure DMVPN in a way whereby branches or spokes speak to each other when they need to communicate across a VPN, rather than going back to the hub or the HQ or the central location in order to sort of pass that traffic. So we've got two ways we can configure this, and it really depends on sort of what the organization is trying to achieve. So I may cover each method in our labs, maybe not this session today. We will look at sort of the hub and spoke method today, and maybe in an upcoming video we can focus on a full mesh spoke to spoke VPN deployment. Now DMVPN is dynamic, and it allows for us to be able to really achieve that full mesh or partial mesh deployment by making use of GRE. So we can either use MGRE, which is going to allow us to actually make use of DMVPN in the first place in a dynamic nature, and we can actually use a mix of MGRE maybe on the hub, and then if it's a hub to spoke deployment, it would be, we would really look at GRE on the spokes. But if you wanted that sort of full mesh deployment where the spokes could speak to each other as well, and we could also look at actually making use of MGRE in order to allow for that as well. We'll see, you know, like I said, we'll get into this a little bit more in the lab to see how these configurations actually work and what it looks like. NHRP, our next hop resolution protocol, is used to resolve the peer destination addresses, and automatically based on that, once resolved, create those peer-to-peer tunnels. With regards to configuration steps, we have the hub configuration and we have the spoke configurations. Both are very, very similar. There's a few things that will change depending on the way that you configure the spokes, but for the most part, everything is pretty much the same. So if we look at the hub configuration, we have the optional configuration of the IKE v1 or ISA KMP policy. We have the ability to, or we need to actually configure a key. So either a pre-shared key that's going to be shared across the devices participating in the DMVPN, or we can actually make use of PKI as well. So we can actually make use of certificates and stuff to actually form that relationship between the peers as well, if we choose to do so. The next step, which is the configuration of the phase 2 or the transform sets, is also optional as well. So we actually have, if you watch my previous videos, you'll know that we actually have some default parameters that will be used if we actually don't configure anything. So these steps are optional as well. In step 4, this is where the bulk of the configuration comes into play, I would say. And this is where we, from a hub perspective, will configure the tunnel interface. And then on the tunnel or within the tunnel, we'll configure it for MGRE, and we'll cover some other parameters such as an HRP configuration, IPsec, transform, binding. We'll look at sort of the MTUs, adjusting them, as well as the MSS settings as well. Similar on to the spoke side, you know, we've got the optional ISA KMP policy again. Again, we need to make sure whatever we configure on the hub is the same as the spoke with regards to whether we use a pre-shared key or whether we're using certificates. Again, with the transform set, it's optional. And then on the actual tunnel interface, we can choose to configure MGRE, or we can configure GRE if it's just a partial mesh, if you like, as well as the information about the next hop server, which is going to be the hub, and also the rest of the same configuration, such as NHRP, IPsec configuration, MTU and MSS settings as well. Again, don't worry too much about that because we will look at this all in the lab in more detail. Now, just before we do get into the lab, I just wanted to sort of break it down a little bit more just to give you a better example and give you a better idea really of what it looks like. So with our optional IKE policy, we can configure our encryption, hashing, authentication, lifetime group for our policy if we choose to do so. It's optional because, as I said, we do have defaults that will be used if a policy is not configured. We then move on to whether we choose to configure a pre-shared key or use PKI. So in this example here, we're actually using a pre-shared key. So we can see that we have our key Cisco, which is going to be applicable for our peer. That's at the physical address of 209.209.209.10. Again, transform set is optional, so we can configure this, but if we don't, then we will just leave this as default. And then onto the tunnel interface configuration, we start to look at applying an IP address. So this IP address at the top, and the reason I've highlighted it is because I want to show you the main differences between the hub configuration as well as the sport configuration. So with the IP address here, we're actually assigning a tunnel IP address. So this is a total different IP address from the physical interface, and we'll map this to the physical, the outbound or the outside interface a little bit further down. So we set our MTU for our traffic, and then we go into our NHRP configuration. So we configure authentication for NHRP. We can configure a network ID for NHRP. In this example here, you can see that we're using multicast dynamic. So this basically means that we're dynamically going to peer with our spokes here. And you'll see the difference on the spoke configuration in a moment. We have some MSS configurations. We have the tunnel mode GRE multipoint, so you can see there that we're using MGRE there. And then we've got a tunnel key as well. And then lastly, we tie in on the bottom here, we tie in our tunnel protection with our profile that we created here, our IPsec profile. Again, if you don't create one, you can just use default as well, and we'll take a look at that as well. Similarly, we're using pre-shared keys again, so this is going to reflect the hub's IP address in this case, because we're now looking at the spoke configuration. Now, if we just jump straight down to our tunnel interface, we can see again we're assigning an IP address for our tunnel, and then moving on to the NHRP configuration, we can see here we're mapping the multicast to our hub physical IP address, and then we're going to map our server address, so our hub, we're going to map that to the physical IP address of the server as well. So that's going to be the tunnel interface IP of the hub, and that's going to be the physical IP address of the outside interface of the hub device as well. The NHRP network ID is going to be the same for the for NHRP to work, if you like. And then we've got our next up server. We can see that we're pointing the next up server IP address to the tunnel IP address. So important to point that out there. So we're pointing that to the tunnel, not the physical IP address of the hub. And then our tunnel source is going to be mapped to our outside interface. So Ethernet 00 in this example is the outside interface of the spoke device. And then and I won't scroll down there because it's just going to put on that pop-up icon thing. But we can see here that where we have the last highlighted in red there, we can see tunnel mode GRE multipoint or tunnel destination. So we actually have the option to configure MGRE, and that's if you want to allow for a spoke-to-spoke deployment as well, so full mesh deployment if you like, or we can actually specify the tunnel destination, which is going to point to the physical IP address of the hub if that's just a hub to spoke deployment or a partial mesh deployment. Tunnel keys and tunnel protections are the same as well, based on what we've configured in this particular example. So I just wanted to point that out really, because when I first started looking at this, I would get a little bit confused with which IP addresses would apply to the outer layer and inner layer as well. So hopefully that makes a little bit more sense. So this is a topology that we're going to be looking at today. So just to cover it quickly, on the top right hand side, we have a partner site. We have in the middle there, we've got our fictitious ISP, if you like. And then we have on the bottom left hand side, we've got branch 1. Branch 1 is now going to act as our hub. So router 10 or R10 is going to act as our hub device. And then we've got branch 2, which is going to be a spoke for on router 8 or R8, as well as R11, which will also be a spoke. So I think in this particular video, we'll look at configuring a hub and spoke DMVPN, and then maybe in an upcoming video, we can look at the full mesh deployment as well. So where spokes can communicate with spokes as well. Ignore the top left hand side, the ASA, we're not using that in this particular demonstration today. You can see we've got different BGP AS numbers, so we've got BGP established between all devices, but our internal networks or the networks behind our routers cannot reach the back end of any other site, and that's where DMVPN will come in. So we'll look at actually configuring some dynamic routing across the tunnel as well. And then lastly, we've got our tunnel IP addresses that's specified on the left hand side there. So 192.168.10.1 and 192.168.10.4 as well. Or should I say 10.1 to 10.4, but we're actually only using 3 in this example. So without further ado, we'll get into our lab. And as I said, everything is, if I just show you quickly the config, everything is very, very basic here. So we just got our BGP configuration, our interface configuration, and that's it, nothing else on here. I've also made the image on the right hand side of the screen now that you can see a little bit bigger, so that hopefully you can see and refer to that as you need to go through this lab as well. So if I just do show IP route, we can see that we've got our BGP routes up, but we cannot from our devices. So this is VPC2 on branch 1. We cannot, if we try to say ping the partner site, device VPC3 at the top right at 10.0.10.10. You can see there that we get destination host unreachable. So we need to make the relevant changes so that we can actually reach each site, if you like. And that's what we're going to do in this particular lab today. So I won't run through the other devices because it's all the same basic configuration. What we'll do is we'll get started with the hub configuration, and once we've done the hub configuration, then we can start to look at configuring the spokes as well. So as I said, if we just quickly flip back here, as I said, with the configuration elements here, we actually have the IKE policy, which is optional. So for the purpose of this video, we'll leave that. We'll configure our IKE pre-shared key though. We'll leave the transform set. We'll use the default one, and we'll see how that works if you've not seen that in action before. And then lastly, we'll configure our tunnel interface configuration as well. So if I start off now with crypto key, and then we say crypto ISOCAM key rather, and then we give it a key of Cisco, and then what we need to do now is we specify the address of the peer. So we're going to have 2 peers in this case. So we've got our first peer, which is a partner site, route 11 on our top right hand side. So that IP address is 209.209.209.10. And then we can specify our mask. And then we have our bottom right hand side peer, which is branch 2. at .14, and we can give them the same keys. If you wanted, you could change the keys. We'll just keep it simple and give them the same keys. So once we've done that, talking about sort of how easy it is, as I said, we don't have to configure no phase 1 policy if we don't want to. Phase 2, we don't have to configure. There is a default one. So what we'll do now is we'll jump straight into our tunnel. So we'll create our tunnel. And as I said, because this is the hub, so things are going to work slightly different here, as opposed to, you can see the slightly more configuration there in the spoke. With our hub configuration, we're just going to now configure that IP address on the tunnel. So that's going to be, if I just scroll down here, so that's going to be, if we say IP address, and you can see as well that the tunnel is down at the moment. So the line protocol's on, but the tunnel's down, the state's down. So we'll configure our tunnel IP address, which is 192.168.10.1. And we'll just give it a subnet of /24. We'll specify our MTU at 1400. We'll also tell you what, actually, we're going to our NHRP configuration. So we'll say IP NHRP, and we'll start off by authentication. So we'll start off by configuring our authentication, and you can see here this is just a simple string that we can configure as well. And this value needs to be the same on all the spokes that are in the same DMVPN network. So we'll just give this Cisco 123, for example. And now we'll do our NHRP map. It's a bit of a tongue twister, that, so I need to say it a little bit slow. NHRP map. And because this is the, so if I just question mark here, you can actually specify our IP address of the destination, or in this case, because we're using the hub, or this is going to be configured as a hub, we're going to specify multicast and then dynamic. So you can see here that we've got dynamically learned destinations from client registrations on the hub. So we're going to say dynamic because this is the hub. And then once we've done that, what we can do is we'll specify our NHRP network ID. And this number can be anything up to 32 bits. And this is for our non-broadcast multi-access network. So we'll just specify 1 in this example. And then what we'll do is we'll do tunnel source, which is going to be our outside interface. So this is going to be Ethernet 00. And then once we've done that, we can actually specify a tunnel key as well. And again, this key needs to be the same. So the tunnel key and the network ID, they all need to be the same on the other devices as well. So we'll specify the tunnel key. And if a question mark there, you can see we can also specify a value there. So we'll just say, let's say tunnel key 100, for example. And then we need to say tunnel mode. And you can see we've got a few different modes here. We're going to say GRE, and then because it's the hub, it's going to be multipoint. So this is for our MGRE. And now you can see that tunnel state has changed to up. And then lastly, what we can do is we can, well, one of the last things actually, we can specify now our tunnel protection for the IPsec. And we didn't create a profile, so we can use the default one. So if I just type default there, you can see the ISKMP is on, and we specified the default IPsec profile to use. We can adjust the maximum segment size. So we'll adjust the MSS to, let's just say 1400. Now I'll tell you what, actually, we use the recommended value, which is 1360, if I remember correctly. And then we could configure some old timers, etc., but let's leave it at that. I think that's enough. So if I do show interface, do show run interface tunnel 0, we can see that we've configured our IP address, MTU, we've got our NHRP authentication now, we've got our network ID, which needs to match, these two need to match on the spokes. We've adjusted our maximum segment size. We've got our tunnel source, which refers to our physical interface, our outside interface on this router. We've got our MGRE configured. We've got a tunnel key configured that also needs to match on the spokes. And then we've applied our IPsec profile, which is going to be using the default profile as well. And if I just do show IP interface brief, you can see now at the bottom there that that tunnel is up. Let's have a look at do show crypto ISKM PSA. We still don't have any SAs yet because we need to configure at least one peer so that they can build that tunnel as well. So what we'll do is we'll actually move on to configuring the P&L. So we'll leave this as it is right now. We won't do no routing yet. We'll just move on to, let's see what's next here. Is this router 11? Yeah, let's move on to router 11. So we'll move on to the partner site now, which is at the top right hand side. And if we start off with crypto ISKM key, and we're going to use our key and we'll specify our address. And as I said, we're going to be using hub and spoke deployment here. In our next video, we'll do spoke to spoke as well. So we'll just specify our address to be the hub IP address on the outside interface. So it's 209.209.209.6. And that needs to match with the hub as well. So the key needs to match as well. Oops, I don't need to do that. And then once we've done that, again, like I say, I'll use the default IPv1, default IPsec or phase 2 configuration that we've got. So we'll jump straight into our tunnel, and then we'll specify our IP address of 192.168.10.2 this time, because .1 is the hub. We'll also specify our MTU, which was 1400. We'll then configure our NHRP authentication. And let me just quickly go back here, see what we did. So authentication, Cisco 123. Cisco 123. And then once we've done that, we can configure now our, because we are using our, or we're connecting back to our hub because it's our spot, we need to do NHRP. We need to map our tunnel address 10.2 to our physical address 209.209.209. That's the server, so I need to do 209.209.209.6 there. So this is going to map our or it basically defines the NHRP server at the hub, so our hub server, and that's mapping our the tunnel IP address to the physical outside interface IP address. So once we have done that, then we can do NHRP, IP NHRP. Let's do map multicast, because we're going to need to, so this is going to actually enable us to use dynamic routing between the hub and spoke to send us multicast packets. So we need to enable or configure this. So we'll do IP NHRP map multicast, and we're going to specify here our NHRP server address. So this is our router 10 physical outside IP address. Okay. And so once we've done that, we can actually configure now our next stop server. Next stop IP NHRP next stop server. And that's going to be the tunnel IP address this time of the hub. So this is going to be 192.168.10.1 IP address. And then we need to do our IP NHRP network ID. And if we just go back here, we said our network ID was 1. And then we need to also specify our tunnel source, which again is going to be our outside interface on this router. So this is going to be Ethernet 00. And our tunnel key we said was 100. Again, this needs to match with our hub. So we said tunnel key 100 there. And then once we've done that, we can specify either whether we choose to do at this point MGRE or just specify a destination, which is going to be just GRE. So if we said tunnel destination, you can see here we have it's tunnel mode. So tunnel mode would allow us to specify MGRE, but tunnel destination is what we're going to configure. Is going to give us the ability to specify an IP address, and that IP address is going to be the physical IP address of the hub. So 209.209.6. Now, if we're doing MGRE for spoke-to-spoke connectivity, then that would change as well to MGRE. So we'll maybe see that in a different video. What we need to do now, that tunnel state's changed to up, but what we need to do now is we actually need to configure our tunnel protection. So tunnel protection IPsec profile, and we're going to use default because we didn't configure one. So you can see there that we're using default. And then what we can do is we can adjust the MSS again. So IPTCP adjust MSS, and I said 1360. And then we won't configure any hold times or bandwidth, etc. We should be all right for this lab. So if I just do show run interface tunnel 0, you can see slightly more configuration on the spokes, or slightly different to the way it's configured as opposed to the way it's configured on a hub. But nevertheless, it's still not too bad to be able to complete the configuration to form those tunnels. So really we should have a tunnel actually already established now. So if I just do show crypto ISACM PSA, so you can see we've actually got a security association now between our source and destination. Our source is this device here, so router 11, and our destination is our hub. So our source has established that that tunnel with our hub, which is great, and you can see status active. So if I do show crypto IPsec SA, we can see there that we've got some security associations as well, which is great. So now you can see our tunnel 0. We can see the associated IP addresses for local identity and remote identity. And we can see here that we've got some in-caps, or at least one in-cap, one D-cap as well, which tells us that this has been a successful configuration as well. We can see here our inbound ESP. We can see the transform that we're using as well. Again, we didn't specify that. That was by default as well. And likewise, we can see the outbound as well. So great, that's everything configured there. So really we should be able to actually test now. So if I go back to VPC2 on the branch site and we try to ping our partner device now, it's not working. And I know why it's not working, because we've not configured the dynamic routing. So what we'll do is we'll configure our last branch. So we'll configure branch 2 rather before we actually look at configuring dynamic routing and testing that connectivity. So you see there, even though we've got that tunnel established now, we still need to let each or let the tunnels know about our interesting traffic, if you like, and we do that with dynamic routing or routing. So we'll do that afterwards. So for now, let's go on to our router 8, this one. And again, we'll do crypto, ISOCAM, key, Cisco. And I'll just quickly go through these because, we've already kind of covered it twice on the other devices as well. So we're going to say 209, 209.6. Interface tunnel 0, IP address is going to be 192.168.10.3 this time. Okay. The IPMTU 1400, IP and HRP authentication was said Cisco 123 if I remember correctly. Yep, Cisco 123. Okay. Do IP and HRP map, and we're going to map our hub tunnel IP address 10.1 to our hub's physical IP address, which is .6. And then once we've done that, we can do our IP and HRP map multicast, and we're going to specify our hub's physical IP address, and this is for our dynamic routing. That's fine. And then once we've done that, we can then let's do our next stop server, NHRP next stop server. And this is going to be our tunnel IP address of the hub. So this will be 10.1. IP, NHRP, network ID. I think we gave it 1 if I remember correctly. Yep, network ID 1. We'll specify our tunnel source, which is Ethernet 00 on this device as well. And then we'll give our tunnel key, which I said was 100. And then once we've done our tunnel key, we can specify our tunnel destination. And then we're going to specify the physical IP address of our hub. Tunnel destination 209.209.6. That tunnel comes up now, and then we can specify our IPsec profile. So we'll say tunnel protection IPsec profile, and we're using default. Let's adjust our maximum segment size to 1360, and we should be good there. So do show IP interface brief. You can see the tunnels up on this device. Let's do show crypto. We can see there that we've got a tunnel as well. Let's do IPsec. That's good. So we can see that as well. And if we go to our hub now, let's have a look what we've got here. Oops, I've just started translating. So let's have, when this is finished, annoying. So they've done an IP domain lookup. But when this is finished, we'll just take a look on the hub. We'll take a look at both of the tunnels, make sure everything's up there, which we should already know that it is. So you can see we've got two security associations there with both branch 2's device and the partner site device. Let's do IPsec SA. So the first one, you can see we've got tunnel 0 with our what we're matching here. Remote address is 14, so this is actually matching with our branch 2 site. And then we should have another one down here. There you go, matching with our partner site as well. Cool. All right, so now that that's done, what we can do is we'll configure. Let's do a show IP route. In fact, you can see that we've still got the same routes. Well, additional, we can see the connected and the local routes of the tunnel, which is what's expected. But we still don't see any information about the networks behind each site, and this is what we need to get to. So what we need to do is let's configure OSPF. So we'll say router OSPF 1, and then we'll say network, and we'll say 192.168.10.0, and we'll specify our wildcard, and we'll give this, let's just give it area 0. And we'll also specify on this device 172.168.2.0.0, and this is our internal host. And cool. So once we've done that, let's go across to route 11, which is our partner site. Let's do router OSPF 1. Let's say network 192.168.10.0, area 0, and we should see this adjacency form. Oops. And then we'll also do, there you go, so you can see our network, our OSPF dynamic routing adjacency is being formed. We'll just add in our 10.0.10.0 network here, area 0. And you can actually see that's formed on tunnel 0, which is perfect, which is what we want. And the last one we will do on router 8. So let's do router OSPF 1. We'll say network 192.168.10.0. And then we'll do network 172.16.30.0, area 0. All right, cool. So let's have a look now at let's go back to our hub actually. Now you see it's not going to work the way we would usually expect it to work with DMVPN, as you can see here, because we are using OSPF with DMVPN is not the best solution. So what we actually need to do here is let's just quickly take away these. Processes, and then we can start again here. At least you got to see the sort of the issues you can actually have with, let's come out of this, with doing a standard OSPF configuration. So what we'll do now is because it's link state, it doesn't work the way that we would like it to do, because in the tunnel all the devices share the same IP range, if you like. So we need to actually configure it a different way. So point to point is not going to work. We actually need to maybe use one of the more recommended approaches with DMVPN, which is actually, or usually the preferred option is to use point to multipoint configuration. So we can take a look at that, and we'll see how that works as well. All right, so if we just go back to our hub device now, now that we removed those configs, you can hopefully now see why the point-to-point or the traditional way of really configuring OSPF does not work. So we have to slightly change the way that we do it. Still possible, but we just need to change the way that we do it. So to do that, if we're just going to well, what we're actually going to do is we're going to configure point to multipoint, and then we'll verify that the traffic still passes through the tunnel. So if we just do interface tunnel 0, and then what we need to do is need to say IP OSPF, and then we can say on this particular instance we want to do network, and we're going to say point to multipoint there, and we need to do this on all the hub as well as the spokes as well. So if I just go into tunnel 0 here, IP OSPF network point to multipoint, and then lastly we'll do the same thing on router 8, and first tunnel 0, IP OSPF network point to multipoint. And then once we've done that, we'll go back into OSPF now. So we'll say root OSPF 1. And now what we'll do is we'll just simply specify those same networks again. So we'll say 192.168.10.0. Area 0. And then also we'll specify for router 8, our internal network is 1630.0. And then we'll go back down to route 11, route OSPF 1, and we'll configure network 192.168.10.0, area 0, network 10.0, 10.0. And you see now what's not happened is there's been no adjacency, because you can see everything needs to go via the tunnel. So even though we've configured OSPF between essentially the spokes, we need to go via the hub, and we'll see this now. So if we do a route OSPF 1 and we specify network 192.168.10.0 and specify area 0, we'll see that adjacency form with both networks there. So you can see that's formed. Let's just add our 1620.0 area 0. All right, cool. So now let's have a look. You can see we're not getting those issues we were getting with all the logs coming up because the adjacencies were basically all messed up. We should be good now. Do show IP route. So what we can see is we have 10.0.10.0 network, which is via 10.2 through the tunnel, which is right. So that's going to our partner site. Now, if we look at where 172.16.30 is, we can see that's going via 10.3, which is router 8's tunnel interface, via the tunnel as well. So that's good. And then you can see we've got our 10.2, 10.3 adjacencies formed with the tunnel as well. So that's on our hub. That's great. Now let's have a look at what it looks like from a spoke perspective. So if I just do show IP route now, we can see that anywhere, if we want to, so we're on router 8, so this is down at branch 2 on the bottom right hand side. So we can see that if we want to get to our partner site network at 10.0, 10.0, we actually need to go via the hub, which is expected. So we need to go via 192.168.10.1 via the tunnel. And then if we want to get to 172.16.20.0, we again go to our hub as well, and you can also see that we have our adjacencies formed with the tunnels. So you can see that even though we have our adjacency here with 10.2, which actually has the 10.0.10.0 network, we still actually have to go via the tunnel to get there as well. So yeah, that's the OSPF situation out of the way. Let's go back to closing out now. So we should actually, now that all the configuration is in place, we should be able to test our connectivity now. And we already know by the routes that this should now work. So if I now try to ping from VPC2 on the bottom left hand side, I should be able to ping the partner site as well, a partner site VPC3. And there you go. So you can see I can ping that, which is great. And then likewise, let's go to VPC3 and let's try to ping. In fact, what do VT? Let's do VPC4. Let's do this. Let's just restart that. It looks like it's doing this annoying thing when you don't touch the VPCs for a little while. It doesn't let you do anything on it, which is a little bit annoying. But nevertheless, I cannot be bothered shutting them down just to quickly reconfigure them. So what I'll do is I'll just make use of this. We can see that we can ping our VPC3, and let's try to now ping our VPC4 from branch 1, which is where our hub device is. So if I say 192.168 on 172.16.30.30, you can see as well that that's successful as well. So we have got connectivity now, which is good. If I just do show crypto IPsec SA, you can see that we've got in caps and D caps as well coming through, which is good, what we would expect. Now, if we want to take a look at some of the other commands that we have available for our configuration, what we can actually do is we can issue a few commands here as well. So we've seen the security association for phase 1. We've looked at phase 2. We could also do show crypto map. So you can see here we've got our tunnel head information. We've got the peer. We've got the permitted IPs. So you've got a few bits of information there. You've got the transform set, so you can actually see, and you can see that we're using default as well. We can see the tunnel interface, tunnel 0. We can actually do show DMVPN. You can actually see here our peers, our peer information as well, which is very useful. We can see the uptime. We can see whether it's up. We can see our peer addresses. So these are the physical addresses mapped to our tunnel addresses. I think you got DMVPN, yeah, detail. This gives you a little bit more information about the target network, really. And you can see here that we're using MGRE and multiple multi-GRE here. What else have we got in here? Yeah, we've got our tunnel information, our IPsec information, which we've already looked at as well. We can also do show IP NHRP traffic. So you get to see as well, where are we? Yeah. So we get to see information about sort of the NHRP traffic. So we've got registration replies. We can see, this is really good to see if there's any issues with NHRP as well. So we can see that we've got 13 registrations. So this will look different on the Spoke. So if we just go to the Spoke, do show IP NHRP traffic. So you can see don't have no registrations, and that's because we we are a spoke, or this device is a spoke. But what you can see is we've got 13 registration replies as well. And then we can also see that we've actually requested to register with our server, which is the hub device as well. So slightly different bits of information as well, and that can be useful for sort of identifying what role is each device is playing essentially. If we also do show DMVPN here, or let's do DMVPN detail, we can actually see where we're using, let's go up here, where we're using MGRE here on the hub, as we already know. We can actually see here for our spokes we're using GRE here as well. And then you get the same crypto session information further down as well. We're pretty much approaching the top of the hour now, so I will leave it there. We've managed to configure DMVPN up to spoke deployment. I hope you found this video useful. Please do like and subscribe if you have done, and if you want to follow along with more new content that I release. In the upcoming video, what we'll do is we'll maybe look at configuring this again, but we'll configure this so that we can have the spoke-to-spoke communication as well, and we'll see how that looks with the dynamic routing as well. Thank you for watching.